about to do something that's going to make me cry, so I apologize. Don't suck on a peppermint while you have a mask on. Makes your eyes burn. All right. What group number is aluminum in? 3. How about potassium? And magnesium? Sodium? Chlorine? 17 or 7. Once you get into the teens, just subtract 10. You got it. Fluorine? Nitrogen?
5.
Oxygen?
6.
Hydrogen?
1.
Carbon?
4.
Iodine?
7.
Calcium?
3.
And sulfur.
6.
Okay. Now, how do we remember how to tell if it's going to give or take and share?
Go
ahead.
If it requires more than 4 transfer, I don't know.
Yeah.
Their goal is to get to 8 or
Yeah.
to get to 0, and if it requires more than 4, depending on where it's at, it goes up.
Okay, that's excellent. That's excellent. I can simplify that a little bit for you. If it's a metal, it's going to give away. So let's find our metals. So here's one. There's one. And we treat hydrogen like it's a metal because it generally does give away its electron. So give, and give. Okay. So less than 4, it's going to give away. Greater than 4, it's going to take. And so your question is, okay, that's great, Mrs. Daniels, but what do we do if it is 4? Ideas?
It can be either.
We're going to do both. Mm-hmm. Yeah. Most of the time, they're going to share and they're going to take. Rarely are they going to give away. But that doesn't mean it does not happen. There are some compounds that make up life where it actually does give them away. So speaking of, here's our carbon. We're going to say that it takes, shares for the most part. Okay. So knowing that non-metals are going to take or share, we can now complete our table. Take or share. I'm sorry my S's look like that up here. When I write them with pen and paper, they don't. I just ordered the rest of our lab supplies for the lab we have coming up. I'm excited about that. Some of them were on back order, so I had to cancel them and order from someplace else. That didn't make me very happy because that's a pain. All right, everybody take a deep breath. Get your big breath. I'm fogging up. Okay. Did we get the oxidation numbers written down on our periodic table? Okay, good. All right, so there's a couple of different ways to look at oxidation numbers. They have nothing to do with oxygen, so I don't know why they're called that. I'm not a chemist. But one of these days, I'm actually going to ask one why they're called that. But the way you tell their oxidation number is a couple of different things. You look at their valence numbers, their group number, and you figure out how many more do they need to get to 8. But you can also look at their property. Are they metals or non-metals? Because if they're metals, we know that their oxidation number is going to be positive or negative. Positive. Because we know that they're giving that negativity away. Okay? So I always like to start with my metals. Just because to me, it makes sense. There's more of them on the periodic table. I'm less likely to confuse them. All right. So aluminum gives, how many does it give? 3. So it has an oxidation number of 3 plus. Yeah, you want to put the plus on there. There are some teachers that don't because it's understood to be there. But I'm literal. I want to see it. Show it to me. I grew up in Missouri, the show me state, you know. All right, potassium is going to give how many? 1. So it's going to be a 1 plus. Okay. Magnesium is going to give how many? 2 plus. And sodium is going to give how many? 1 plus. I'm going to skip my nonmetals. Nothing personal. Hydrogen is going to give, so it'll be a 1 plus. And then we have calcium is going to give 2 plus. So your metals will have a positive oxidation number. Your nonmetals will have a negative. Your metals are positive because they're getting rid of negativity. Your nonmetals are negative because they're taking on negativity. They need more electrons to fill that outer shell. All right. How many more does chlorine need to make 8?
1.
So it's going to be a 1 minus. And look at that. Fluorine and chlorine are in the same group. So it's also a 1 minus. Nitrogen, how many more does it need? 3. Needs 3 more electrons to fill its shell. Oxygen?
2.
And carbon, of course, we know does the plus or minus thing. Carbon's just friendly that way. Iodine? 1 minus. And then sulfur. Stinky sulfur is a 2 minus. What questions do you have over this? I know this is a little repetitive, but I'm not going to see you for a few days this week. The next time I see you, we'll be reviewing, and then you'll have a test on Wednesday. And then on Friday, we're going to start on covalent bonding. Okay. Whenever you talk about ionic bonding, you always think back to your Lewis structures. Because I promised you I wouldn't make you do any more Bohr structures. Unless you just want to. I don't know why anybody would really want to. All right, so what you want to do is you're going to look at your periodic table. What group is Na in?
1.
It's in group 1. So I'm going to write that above there. And what group is chlorine in? 7. Does anybody want a piece of paper to do this on?
Yeah, actually. Wait, can we just use one that we used last time?
Sure. You have room? Would you like a piece of paper? You're good. Okay. Some people can do it on the computer, no problem. Some people like. Okay. Anybody else? All right. So I just like to list the group numbers because it helps me. So the next thing I need to do is I need to write the Lewis structure for each one. So Na, there's this Lewis structure. I know that it has one dot because it's in group 1. And then I have Cl, and it has 7 dots. So chlorine's got 7 dots. It's got space for how many more? Got space for one more. And it happens to be in luck because sodium's like, oh, hey, I've got one. Here, take it. So sodium sends its electron over to chlorine. Chlorine's like a magnet for it. It's like, oh, cool. Send it over. Got it. And then from there, I can write my formula, which is NaCl. There's one of each. So that made it very nice. Questions about that one? When it's 1 and 1, it makes things so pretty. All right, magnesium is in group 2. Iodine is in 7. So start with your magnesium, and it's 2 dots. All right. Magnesium has to give away all or nothing. And we can't throw an electron away because that's part of matter. So what can we do in order to balance our compound? Go ahead.
Get 2 iodines.
I need another iodine. Yeah. Okay. So just to make it prettier, which can't really do on here. So 1 electron goes to each iodine. Now I want to write my formula. How many mg's are there? There's 1 mg. And how many iodines are there? 2. Remember, in ionic compounds, the metal always comes first. All right, we'll do one more together, and then I'll let you do the next row. Potassium is 1, and sodium is 7. Guess what I probably should do is write the formula up here. Okay. Iodine's got a blank space. Potassium has what? Potassium's got 1 electron, doesn't want it. What is it going to do?
I'll do iodine.
I'm going to give it to iodine. So in my drawing, I have 1 potassium, 1 iodine. All right, I'm going to set a timer. Let's say, what do you think? 2 minutes? No, I'm kidding. How about 7 to do this next row?